Mine were not so happy.
She says, please don't do that to me while your father's still alive.
Yeah, mine were like, I was like,
covered all my bases at once.
No, that's
one
the
on
first
that.
One minute away. Not getting any more. Thank you. I can't even. Alright, good afternoon. I have 3:45, so I want to get us going. I know it's the end of our day, and hopefully it's been a good day thus far, but welcome to CS Disco. This is our computer science party for middle school. I'm sorry I did not have disco music playing as you came in. I wasn't sure if that would bring people in or send them away, so I opted for the for now. My name is Eric Black. I am one of the CS Discoveries facilitators for Code.org in the state of Pennsylvania. On the eastern side of the state, we happen to have 5 facilitators for CS Discovery. I think over here on the western side of the state, there are 4 as well. So we are kind of well covered with facilitators across the state. And I also happen to work in one of the intermediate units in Pennsylvania, Carbon Lead High Intermediate Unit, which is near the Allentown area. Kind of right in the middle of our eastern seaboard of Pennsylvania. I am excited to be here, even though it is 3:45 in the afternoon, and it is the first day of PEC, and I know at the end of the first day of PEC at 3:45, most people are feeling like this. And they are ready for their day to be done, they're ready to pass out, they've had their brain filled, but hopefully by the end of this, you will at least feel somewhat excited and jazzed to possibly take some of the CS Discovery stuff back to your classroom. So maybe by the end you won't be quite here, but a little bit here. So, it's a small room. Tell me about who's in the room with me. Where are you from? What do you teach? West Virginia. Awesome. Thank you. Are you a middle school teacher? I'm hoping. No. High school. Okay, that's good. Computer teacher? Have you taught CS Discovery?
No, I take people in one class this summer, but I do teach.
So you're going to get the very fast preview of your week-long class today.
Awesome.
And West Virginia as well?
West Virginia.
High school?
Computers. Special education.
Okay, excellent. Come over here. These are my hecklers. I know who they are.
Wait, I taught that grade.
I'll come back to them, but I know they're going to come here to heckle me. Right inside of the state. Excellent.
Right, we also pray by that.
Is anyone in your school adopting CS Discoveries yet?
No.
That's why we're here. Excellent. Excellent.
Woodland Middle School District, right outside of the city.
Excellent.
So bus here today.
Very nice.
Instructional technology coach. I'm in K-5.
Okay.
So
This is kind of that, what comes after what we see in CS fundamentals. Very good. So some of your, this might be appropriate for some fifth graders. You might find.
also just tailor it down.
Exactly. Exactly.
Justin Rodriguez, tech coach, also Woodland Mills, about 12 miles away from here. I do work at a true middle school, 6 to 8.
And any implementation of CS Discoveries yet?
Not really.
No. Okay.
Tracy Powell, Master School District.
Excellent. Excellent. Good context. And?
I'm a librarian and a specialist in technology coach. South Central being right above the camera.
Okay, what district? Okay, excellent. I happen to do a lot of CS Discovery training in Southern New York, So I became a little bit familiar with that area because I got to spend about 9 days there. so I kind of became a little bit more familiar with that area. And any implementation of CS Discoveries yet?
We are just at the beginning of like our PA Smart journeys.
Perfect. I did see, but I'm going to make you guys introduce yourselves as well because, like I said, I brought at least a few people to knowing I was at 345. I had to bring on a little bit. So.
I'm Gretchen Rustino. I work for TAC, an educational technology company. We do a lot of support with STEM professional development that aligns to STEM products, and then smart technology.
My name is Chris Weaver. I'm the VP of Instructional Solutions.
And I am Tian Oli. I am an instructional technology specialist at Harris IU, we are in the same department, and I
And we were just introducing ourselves, so can I?
my name is Ayana. I work for University. I'm actually director of technology there, so I do with the students.
Okay.
But right now I'm in the block committee, so I really like to see
Right. Excellent. Okay. So you have some ACS discovery. Alright, this is great. So really the goal today is to learn about the curriculum itself. What is the CS Discoveries curriculum? What does it look like? How can it work? How does it differ from maybe what you know about code.org? I'm guessing when I talk about code.org curriculum, you think about the block curriculum. You think about all the block programming and the CS fundamentals, course A through F. And what makes CS Discoveries different? Why is it the next level of computer science, and how could this be implemented? Again, whether you're in upper elementary, middle school, or even that kind of first course, maybe a 9th or 10th grade course, this can kind of be a great fit. I put this slide first because this comes from one of the very first activities in the course. It's problem solving activity. Don't have to read it all. I'll give you the gist. You've done this one already? Excellent. So this is a step-up activity where students are starting to work on some problem-solving skills, and this is about birthday tests. Gives them a list of their friends, and which friends are friendly with each other, and which friends, well, let's say, are probably frenemies right now. And they have their, of course, seats for the table, and their goal is, as middle school students, where they're going to sit everybody for their birthday party that's coming up, to make sure that there are no fights at the tables. A little relevant to middle schoolers? A little relevant to adults as they embark on their first wedding journey and things like that. The reason I put this up front is because I wanted to point out that the crux, the entire purpose of the computer science discoveries curriculum is really for students to apply problem-solving principles across computer science. Okay, well, yes, we're going to talk about, you're going to see in the curriculum, there's lots of maybe next level computer science skills and kind of those hard skills. The big thing about the CS discoveries curriculum is everything is taken from the lens of problem solving. So while you may have experienced through code.org a large number of their unplugged activities, you're going to see that same echo in computer science discovery. And it's often one of the first things we hear from teachers when we do our 9 days of training, our full week long in the summer, and our 4 days of follow-up. Oh my gosh, there's so many unplugged activities. Kids get kind of frustrated because they think it's a computer science course and they should be on the computers all the time. But computer science, we know, is not just about the hard skills that we're doing on the computer. It's about how we go about the problem solving. So they use activities like this that are relevant to middle school kids to help them understand that importance of problem solving. So, what are we going to try to do today? I'm going to give you a scope of the curriculum. I'm used to doing this in 9 days, so I'm trying to boil it down to an hour the best I can. You might not get in to do a lot of activities today. I'm going to try to show you some of the pieces the best I can today. We're going to get a little taste of some of the activities that are there and know what resources are available. Do you have to go through 9 days of training to implement this in your classroom? Absolutely not. I'm going to even show you how you can get access to all the teacher resources and not having teachers go through the full code.org training. But I'll also show you at the end of this, if you do want teachers to go through the code.org training, where you can apply to go to that. I know right now, on at least both sides of Pennsylvania, we are offering a number of scholarships for our summer and full year program. And it is definitely a worthwhile venture to have teachers go through that if you can. No, it's not always possible, but you'll have all the options. So, I could spend a lot of time going through the why. Chances are, if you're a person who comes to PDC, you get the why. Why are we teaching computer science? Well, it's all around us. Everything that we do. The Internet of Things. All of those pieces are so important to us. We know that we need it. We know that people want us to be teaching it, but it's just not happening, especially in that kind of middle ground. Elementary school, we're doing a lot of neat computational thinking activities. We're getting students started with block coding. They get to high school and we're ready for some of that like deep HTML course or a JavaScript course or that computer science AP level course. But middle school sometimes becomes that lost land of how do we bridge the gap? How do we get there? This course could be one of those great ways to do that. I'm not going to go through all these slides. Just know that you'll have access to them if you want to. If you've seen any code.org presentations, you know. They always tell you why. We talked about the idea of how do we get to something before AP? How do we get to something before we get too deep? How do we get those students exposed to know, do you understand how to do some of these things like building a website from scratch or understanding how to create an animation using JavaScript without having to go through that full year-long course to get there? This is going to be that sort of introductory level and help bridge the gap between I've done a lot of block coding, but I haven't understood the language that goes behind it. So, where does middle school or CS Discoveries fit? If you're familiar with code.org at all, like I said, you're very probably familiar with the CS Fundamentals courses, the A through F. They have their Express courses, and they're all really built around those block programmings, the games, the mazes the students do, whether it be Flappy Bird, whether it be Elsa and Frozen, even those hour of code activities, primarily built in that kind of block environment. And that's what we see in that A through F, typically used in grades K through 5, but we sometimes see it used in the middle school as well. CS Discoveries is suggested as a middle school 6 to 8, even up to possible grades 9 and 10 if you don't have those intro level courses in your high school. We certainly need that, but it is a much more in-depth and rigorous course. So a lot of middle schools sometimes look at it and say, oh my gosh, that's too much, we can't take it on in a middle school course. Don't worry, we have implementation ideas for you. And then of course, code.org does have an AP course, CS Principles. It's an AP course that can be taken without previous computer science knowledge, but it certainly helps if you have some background. And that's a curriculum that is available typically at the high school level, 9 through 12. So there is a full range of curriculum in code.org if you weren't aware of it. We're going to focus in that middle area today. As I said, all of the activity that you'll see in the code.org CS Discoveries curriculum is middle school based. From the unplugged activities that get students to think about their own lives and how things might affect them, to the project that they need to complete. They're about their own portfolios, or building games that they and their friends want to play. It's going to be more about what's interesting to them, or how does it affect their own peers. They are going to engage in authentic creation. They will build things from bottom up. That website, yes, we use Google Sites to kind of piece together, but it would help them to know some HTML. They're going to learn the HTML to put together a portfolio and start it from a blank screen to a finished product. They will have the opportunity to build an app that functions. Will it function as beautifully as a PC app? Oh, maybe not. But it will function. It is built to support new CS teachers. Certainly, our middle school teachers may not have the background in computer science that our high school teachers that are teaching some AP courses might have. The way that this course is built is to allow that teacher to be that lead learner. Help them guide students through the next steps and provide the resources that are needed to make sure that the students can continue to guide forward. One concept that you'll see me talk about later, but I will say now, ABCCED, activity before concept, concept before vocabulary. It is a tenet in this computer science discoveries curriculum. Students get active, they start doing stuff. They screw up, they make mistakes, they start figuring out how it's working. Activity before concept. Then, what was that you were doing and why did it work that way? Concept. Alright, now let me help you define that concept. concept, this is what it's called. So as we heard this morning, kind of pulling that out in a different way, not starting with the vocabulary and working through, you start with the activity and work backwards to the vocabulary. All right, I'm going to dive in. I have 6 units to show you about, give you an idea of how this works, and then talk a little bit about implementation. Trying to do this in an hour feels a little bit like that. I've watched it enough times to never hit. So, this is a typical implementation. This is the standard, take it out of the box, suggested implementation. Full year course. Semester 1 has 3 units. Semester 2 has 3 units. Raise your hand if you're in middle school that absolutely has the availability in your schedule to do that. Yeah. That's exactly what we hear all the time. So please know that if this isn't your schedule, this isn't what can fit, no, that's okay. There are definitely other ways to implement this and other ways to grab and kick and pull. And or, as one of my teachers in Philadelphia told me, hopscotch within a curriculum to make it work. So there are lots of ways, and we have some suggestions, but certainly other schools take it on and make it their own based on what they learned about the curriculum. Unit 1 starts with problem solving. Unit 1 is entirely offline. It's an unplugged unit. We need to get our students thinking about that soft skill of problem solving, using the problem solving process as defined by code.org, but very similar to what we see in many problem solving process. Define, prepare, try, reflect. Okay, keeping that cyclical process very similar to what we see in maybe engineering design processes, things like that. We're going to use that simple problem solving process through a series of different problems. Ever done the float an aluminum boat in water? Yeah, lesson 1 is starting that sort of problem solving process. So we're trying to get students right into problem solving right away, because everything that they do from unit 1 is taking a problem solving approach to do that. So they have to have that down first. The other part of unit 1 is, what's a computer? How does that work? How does the input, processing, storage, and output create what is now known as a computer? So it gives them the background of, here's the context for you. This is why all these things need to happen. Unit 1 is about a 3-week unit if you do it completely per book, per lessons. As you see, introduction to problem solving is how we start. That seating your guests at the table is lesson 3. Gets a little deeper into exploring problem solving. And then, like I said, we go into what is a computer, inputs and outputs, processing, and their final part of this project is propose an app. Now that you know what kind of things are needed to be input into a computer to make it work and how processing works, what kind of app could you build and present it to an audience? So they're starting off right away, offline, getting into presentation. They're not sitting behind a computer the whole time. They're working in teams, they're talking with each other, they're collaborating. You're going to see a lot of interactivity, again, throughout the whole curriculum. Students are working together, they're doing things, whether they're offline or online, pair programming, all those pieces are still really important in CS Discoveries. Unplugged entirely. Still lots of puzzles. We're trying to get kids to think and really, really think about what they're doing when they're solving problems. Talked a little bit about both chapters. Chapter 1, or Unit 1, also introduces the student practices, our 2 P's and 3 C's of the course. Problem solving and persistence, creativity, collaboration, and communication. Again, all the things that we talked about, we want our kids to have these skills. These are forefront in this curriculum. That's why we step back from the computers. And that's usually what I hear from the computer teachers are, but my desks are all set up with computer stations set, and how do we work around this? And I said, this is where we need to get a little creative. We can kind of move the computers to the side a little bit every once in a while and see how we can get our kids to work together. But this is going to be paramount so that as they work through, as they get into doing more computer work, they're still remembering that, oh yeah, I can talk to somebody about this. I can collaborate with them to make sure I'm making this work right. We don't want to try to backtrack on those things. We front load those. Talked about the problem solving process itself, questions that we try to put into place as we problem solve. But then, like I said, we really get into what's the computer, what are the nuts and bolts here, how does this work? Don't worry. Code.org does a beautiful job with helping to explain everything. So that teacher, if they're not as comfortable with the input, output, storage, you know what? Code.org's got it covered. They have a great array of instructional videos.
Ow. But what makes a computer a computer?
What does make a computer anyway?
And how does it even work?
Hi, I'm Matt. I was one of the original designers of the Xbox. I've been working with computers since I was maybe 7 years old, and now I work on virtual reality. As humans, we've always built tools to help us solve problems. Tools like a wheelbarrow, a hammer, or a printing press, or a tractor trailer. All of these inventions helped us with manual work. Over time, people began to wonder if a machine could be designed and built to help us with the thinking work we do, like solving equations or tracking the stars in the sky. Rather than moving or manipulating physical things like dirt and stone, these machines would need to be designed to manipulate information.
As the pioneers of computer science explored how to design a thinking machine, they realized that it had to perform 4 different tasks. It would need to take input, store information, process it, and then output the results. Now this might sound simple, but these 4 things are common to all computers. And that's what makes a computer a computer.
Don't worry, I'm not going to have you watch the whole thing. But Code.org uses videos like that to help provide that instruction, to provide that information that's needed. While they're going to be doing activities in the background, a card activity where they have to figure out a sorting process that can be repeated and used again so that they learn how that processing occurs based on an input. Those are the type of activities that format what we see here. The end of Unit 1, like I said, finishes with a project where they get to propose an app. This may be an app that later on they decide that they do want to build, or it may be an app that later on they decide, you know what, now that I've learned more, I want to go a different direction. But this is their first attempt to how do we use the problem-solving process to build an app that'll solve a problem. And again, middle school students, typically all about them. What's going to solve problems for them. Unit 2 jumps into web development. So this is where we're starting to get into the meat of actually learning some hard computer science. They will learn about how do we put content onto a web page using a structure called HTML, and how to make it look pretty with CSS. We're going to pull all those pieces together in a web lab environment. So the environment is structured and set up for students to see where they might be making mistakes, for it to highlight for them when something might be going wrong in their program. But then also to show them immediate results, because for middle school students, we need to make sure that they can see it right away. You don't have to do all that writing and then go run it somewhere to hope it works. They're going to be able to see that right away. Again, I talked about the ABC CBV. There's many instances throughout this lesson, or this unit, where students will get in and try things first. Or they're going to go in and look at a website and the HTML that's behind it and try figuring out why is this the way it is and why did that result in this end product. So it's asking them to pull those pieces out. So again, they get into that activity. They get active with the content before they really define it. Teachers in this activity, we always tell them, this is one that they start getting nervous about because they say, well, wait a second, I don't know HTML myself. Am I going to be okay? Yes, you're going to be okay. You're going to be the lead learner here. You might be half a step ahead of your kids, but it's going to be okay. You're going to have some resources to help you out. The web lab itself is going to help highlight places where students might be struggling so that you can kind of look into them. And again, you're going to collaborate with the rest of your class. That kid that really takes into this is going to become a leader in your class. We start looking at attitudinal goals as well, that it's not just about the skills, it's about how we view what we're doing. Students should start seeing themselves in this unit as programmers. They are going to be typing that code. It's a little bit of context difficulty. A lot of my teachers, middle school teachers, say those first few days when they're in the web lab and trying to type the code, they make so many errors just because they type incorrectly. That's okay. Let them make the errors. Let them fix it. Their typing will get better. Broken up into 2 chapters. Chapter 1 is about the content and learning HTML structure. Are they going to learn every possible tag in HTML? No, not at all. This is middle school intro to HTML. We're going to get them to make headings. We're going to get them to put body text in. We're going to teach them how to italicize, do things like that so that they can get that information communicated on a web page. And then we're going to jump to Unit 2 where they're going to just style it a little bit, make it look pretty. Because all that black and white text is going to drive them a little bit. So they're going to want to get into those style sheets. We say, you start with the bones, you build some structure to it, doesn't look pretty till we put clothes on it. And even that doesn't look that pretty. They will learn how to create web pages. These are web pages that they can share. They don't have to be shared. As a teacher, you'll have access to them because in the code.org environment, you create your class and you have access to all your students' work. This is a longer unit. This is why I'm great. You know I'm getting over being sick. This is a 6-week unit if you do it again verbatim. Okay? You'll see 2 projects in this unit, a multi-page website and a personal portfolio website. They build upon each other. So if you start one and you are getting through it in that first part, as you get to week 6, you are just finishing it by styling it. So they're not necessarily 2 separate projects, but could a student finish after unit 1 and not style it? They could, absolutely. They're not going to be happy. They're going to want to style it. But you could finish there. The tool itself, Web Lab. I hate the image they give us because when it's in the environment, it's not black and white like this. It's a white screen to see the HTML environment that they're typing in. Gives them inspector tools, debugging tools so that they can find where errors are occurring, and inspector tools so that when they highlight a spot on their website, it'll show them the code that corresponds to it. So if something doesn't look the way they want it to look, they click on it on their preview, and it'll highlight on their code. Real quick way to find those errors that they might have. At the end, they can publish, they can share, they can remix websites. As they work through, they do things like exploring what websites do, why we use websites, what problems do websites solve. Again, we come back to Unit 1, problem solving. We learn how websites help us with expression and entertainment. One of the first things that they do before they even start learning their HTML, they start with an activity like this. They get a couple of classmates that aren't looking at the screen. They have to start describing to their classmates how they would recreate that. Very often, they miss parts, they don't tell students in the correct order how to fix things, and get these really messy pieces of paper that look nothing like this. Helps them understand the importance of being very succinct in what they're telling a computer, putting things in the right order, so that when they get to typing, they'll hopefully make a few less mistakes. Throughout the process, as they're getting into the each of the units that has more coding involved in it, they will have videos to help them. Videos that they go back to anytime they want to help describe the process. They'll have map levels. Map levels will define pieces of code. You know, what does the /h/h do? The map level is defined. It's kind of like their vocabulary. They have instructions to tell them exactly what they need to do on each level. Tips to say, you know what, if you forget how to do this, here's a tip that'll show you a video that shows you how to do this. The inspector tool, like I said, lets you click on a spot on your live website to show you what's going on. And then the bubble colors lets you know, hey, you got this right, you're done, or you need to keep working through it. So, I'm going to just jump in real quick live, just so you can see. From a student perspective, along the top, those bubbles are what you're used to probably seeing in CS fundamentals, the bubbles as they go across the different mazes. Well, as they're going across here, you see that we start with an overview page, just a quick introduction for us. Then we're moving into an activity page. We start exploring first. Again, action before before concept, concept before vocabulary. They start learning about what the web lab is. Then they get that first video showing them the first pieces of what they should be looking up for in web lab. Again, they can come back to videos anytime they want. I have a lot of teachers that say, you know what, I show the video in class, and then I show the kids how to skip this. Which all they'll need to do is come to the bottom and hit continue. Don't worry, they don't get all the for teachers only stuff. Like I said, instructions to show you what's going on or what needs to be done. The inspector tool. I highlight a part of my live web page, such as here. It shows me where in my code that pops up, so that students can easily track what's going on their website.
They said they felt that the test was more on the web design aspect than it was on the actual.
So which of the AP tests did they take? Did they take AP1, CS Principal, or AP Principals?
I'm sorry,
Principals, from what I've heard, has had some changes in the last couple of years, especially over some of the tasks that they're doing, and I'm not as familiar with it, but I know Code.org has kind of updated their curriculum to match some of the changes that have just occurred in Principals.
Last summer, I was fortunate enough to go, I was selected by College Board to attend their AP
Mm-hmm.
CS in San Francisco, and we were at Facebook headquarters, and they went over like all of the programs that were being approved.
Yep.
Old and new, and some of the old ones they shoved on the wayside of Code.org.
Code.org, yep, CS Principals, and like I said, they've been on staying with the College Board to make sure that they update their curriculum. I know our CS Principals facilitators just had, like, while we get to go back for updates, they had to go back for almost a retrain on a couple of the parts of the course because they had such major updates in the last year. Again, more videos to show what is part of the instructional line of the curriculum. And then, like I said, they have these map levels. These are kind of like our vocab sheets that start highlighting what they're learning, such as the tags for HTML. We always tell our teachers, this is the perfect place to create that word wall. For your students that might need a little extra language support, this is language. We have to make sure that they help see it more frequently in their environment. So a lot of support's built right into the lessons and levels themselves. And again, the teacher has access to see as the students are adding things, they'll be able to see their students' work. Jump in and view. Pull that student up and say, you know what, I see there's an error going on here. I can pull it up when I see my inspector and pull up your account. I want you to just go back in and fix that. They always want the student to go back and fix. They don't want the teacher to fix it for the student. So you won't have the ability to fix their work. You can remix it. You can grab their work and create a copy of it for yourself to show them something, but you won't be able to fix it yourself. I'm not going to show more of the videos, but again, highlights of the videos that are there. They get their first taste of HTML. Chapter 2 moves right into the color classes. They learn about RGB codes, how they're going to start styling their website, making it look good, so that they can put it together in a clean environment. And it finishes with that personal portfolio. I have a lot of middle school teachers that said, you know, this was perfect. We used this to have them start creating that career portfolio that they need. Multiple connected pages, web links back and forth to those pages, live web links out to the web. And then when they finish it, again, it could be shared publicly if needed. just a couple sample projects from actual students. One of our favorites. This is a much more advanced student. Creates a website for everybody that gets an F in art. Some of our more beginner students. Again, functioning websites. Okay? Some may be much more slick and fancy than others. Others may be much more simplistic, but again, built from the bottom to the top. Learning all about the HTML structure, the CSS, but along the way, as they start learning about images, they start learning about property rights, copyright, etc. Unit 3. Okay, we're done with websites. We jump to animation. Okay, keeping with the changing minds of middle schoolers, right? Jump to animation in games. They all want to be able to create a game that they can play. They all want that Fortnite. And they're going to create something more like Pong. Because they're going to start seeing how much it takes to write a Fortnite. Again, we start seeing themselves as programmers. Programming helps us communicate. We're using the problem-solving process, and again, more sequencing and flow for our programming. They start with just how do we create images? How do we layer things on a screen when we're doing animation? And then we start learning how do things work when they are in collision with each other, or moving across the screen and working across the screen. So they start with just kind of those images and animation, and then they start really working with the interaction piece of it in chapter 2. You'll see that this unit, because of the heavy reliance on the JavaScript language, they will have the option of starting with block and then moving to strict typing if they prefer. All of the blocks themselves will have the exact language they need. So it will not be a watered down block in any way. The block will show the text that they would need to type if they took it out of block format. Much longer unit, 7 weeks. You'll see interspersed without the computer screen, those are our unplugged activities. Chapter 1 project is creating an interactive card. So again, just kind of strict animation on a screen. Final project is designing that more interactive game where it can keep score or even be a choose your own adventure type game. Like WebLab, you'll now see a tool called GameLab. Very flexible scope for students to be able to use that. Does have the option of using blocks, and the blocks are provided in a scaffolded way. The first time a kid enters, they are not going to see every possible line of JavaScript code. You'll see the blocks that they need for the tasks at hand, and they'll grow as they need to grow. If they want to go beyond that, well, they can switch over to text mode and start typing in the script themselves. So again, all of the introductory material is always provided in video format from code.org. Many of the sprites, so characters and objects that can be used in these games, are also provided in a library. So again, a lot of pieces that could be used that students don't have to go out and grab extra stuff. They learn about that whole animation process and how it is really a set of images on top of each other. That's one of the hardest things for them to get, and that's where I tell teachers, remember those old transparencies we have probably hidden in a closet somewhere? Hopefully they haven't been thrown out. Because now we can start showing how when you layer things on top of each other, that's how it creates a scene. And if you put your background on top of your sprite, and then you wonder why you can't see your sprite, now you know why. You didn't layer it correctly. So, again, a lot of great ways to kind of bring in tools that we maybe used to use. Chapter 1 ends with the creation of an interactive card. Something real simple, usually a happy birthday card, a Christmas card. A lot of times this is happening around that mid-year point if you're using this throughout the whole year. Chapter 2 gets into how do things work in concert with each other. Where that first animation is, okay, I can slide something that'll say happy birthday. Now if I have two objects on the screen and they hit each other, how does that make something else happen? So that's kind of a big process in the second half of the unit. so that they can really build those games. They learn how to structure the code. Their codes get really, really long through this process. And what we noticed with students that have been taking this, by midway through the chapter, or midway through the unit, they want out of the blocks. They're constrained by the blocks. They need to type it. They're going to take that code that they've been working with and they want to type it because they need to try to do it this way and make sure it fits in this mode. And the nice part is if they make an error, they're going to try to go back to block style. It won't let them if they have an error. They have to fix it in text before let them go backwards. So again, different types of games that they can create in Chapter 2. Where there's a choose your own adventure game, kind of a Flappy Bird type game, Space Invaders games. They're not going to be creating Fortnites, probably. Unless they're putting in a lot of extra work. All right. Halfway through the course. Unit 4 is going back to the design process, but now we're adding empathy. So we've been focusing really on themselves, the kids themselves. Now they're starting to ask questions of others. They're going to be required to do some interviewing of their peers, of teachers, as they start thinking about acts for good. Unit 4 is adding the empathy piece to our design process, and now building an app that's going to be benefit a greater good. Whether it be greater good within their school, greater good for their peers, greater good for teachers, some sort of greater good. So Chapter 1 starts on that user-centered design. They will go through an actual app and start looking at it from the perspective of, well, what problems could this cause if this was intended for X user? And the app that they use, and I want to see if I put the picture in here. I didn't. Aw. The app that they use, it's called Text Your Grandkids. And they get a series of screens, and they start working through the screens, and their goal is to figure out, well, what might cause an issue if grandma was using this? Right? Maybe. But they start talking about not just me, how I would use it, but how somebody else would use it. And that becomes the whole process here as they're starting to build these apps. They start working through that user design process. How do you put a focus group together and have that focus group test things out? What should you be gathering in the focus group? Often, students will start thinking about things that they can solve at their school and ways to create something for good within their school. They will, of course, start with creating physical prototypes of their apps with all of the different screens. Index cards are your teacher's best friend for this one, because kids are going to have lots of index cards with all the different screens for their app and how it will go from one screen to the next. They're doing that through much of the first part of this unit, and you'll notice that they don't get to actually start creating digitally that app until they get to lesson 12, week 4, where they start learning how to use the App Lab tool to design the face of the app as well as the interface, how screens interface with each other and it interacts. So you see that that's in lessons 12 and 13. It's really about coming up with the design first and how it's going to work before we put it into action digitally. Because they are using a language, they're using JavaScript as well as they're doing a lot of their work, they're going to see a lot of familiarity with what they learned in their Unit 3. So they're going to be able to draw on that experience. The design mode for the actual screens themselves is a drag and drop for students. They get reminded that the drag and drop of these screens is just an HTML layer that is being controlled by JavaScript for the activity. So, code.org, to make this process a little more simple for our students, gives them the design mode as far as making the screens for their apps. The functionality has to be programmed with the language itself, though. Talked about user needs. There it is, the Text Your Grandkids. I just didn't get far enough ahead. So they start using those screens to figure out how would this work if grandma or grandpa was using this. And there are definitely problems with that app, beyond the could we turn it on. They do get to recreate an app first too, so they get to learn how to use that design mode before they create their own. Simple projects that were made by students, a safe zone app. So if I use this, the students were able to tell other students, if you're in this part of the building, this is where you should go for your safe zone. So they can click on the app and figure out where they need to go. Unit 5, Data and Society. This is where we're starting to learn about things like encryption and decryption. We're learning about how information is represented online, binary code, all of that sort of depth of information online. Students will, in this unit, have the opportunity to create a kind of BuzzFeed app, if you will. Kind of that, what house of Harry Potter are you, based on the following 4 questions. You're going to learn how do you configure data and how do you cross-reference data that if it is matched in this way, it will result in this answer. Often, teachers are using spreadsheet software in this unit to help students learn how to chart their data and cross-reference it. But then they do have an opportunity to go in and kind of create that app if they so choose. Beyond that, they learn all about the representation. What do those 1s and 0s mean? Why are they created in that way? How has that happened? What happens when we start combining representations? How do we keep data secret using encryption codes and keys? And how do our banks then keep our information safe and secure? Do a lot of activities, again, a lot of offline activity in this one, just so that they can start understanding the very surface layer of how all of that works. And again, final project is that make a recommendation app. I know I'm running short on time. I'm sorry. Optional tools, programming and app lab. So a lot of stuff is coming back now. So as we get to the end of the year, now we're taking a lot of these tools that we were using earlier, and they're being repeated throughout the course. They get to use simple strings of information like this to start decoding. So this is what the coding system is for a specific message. What do we come up with? What does it say? It starts with donuts. Moves to unfriendly, angry. So when you came to breakfast at Pete and C this morning, all the donuts were gone, so you're upset. That's what the message tells me. Okay, the first part of the message is the donut, then it's a thumbs down, and then it's an angry face. So just tells me that we were out of donuts this morning at Pete and C. But what if I wanted to send this message and didn't want anybody else to be able to read it? Then I have to start learning about encryption codes and how we put those together and give only my friend the key. Remember the secret messages we used to send when we were kids? Annie's decoder ring on Christmas Story. You have to set it to this code in order to be able to know what the message is. Drink your Ovaltine. That's what they're doing in this type of activity. Okay? And then again, they continue moving forward. How do we represent that data? How do we start asking for data? How do we pull it into a system so that it creates this output that we need? So, based on the food that you like, you should go to an amusement park. Okay? We talked about using the spreadsheet tools. Again, you can use any spreadsheet tool you choose. And then finishing it up with creating that app if there is time and availability. Final chapter is chapter 6, and that's all about physical computing. It's about the Internet of Things. Now that our entire world is connected to the Internet, and you can't walk into a room without being able to control it from your phone. In fact, I can really mess with my wife on many occasions to come on and off my house when I'm at conferences. Loves when I do that. My son loves it even more. The fact that I was coming back from Florida last week and I was like, oh, I had my temperature turned down and I almost forgot to turn it up. So when we got home, it was still a little chilly in our house. All of those things, I now forget how much has happened with the Internet of Things around us. Well, that's what the whole Unit 6 is about, is to get students thinking about the things around us and how they're controlled by the Internet. So they start working with hardware itself, and the tool that they use is a circuit playground. If you've seen a Makey device or a microbit, circuit playground is very similar, except has a bit more to it. Has a few more lights to it, has a few more buttons, has a few more external outputs, things like that, so that it just has a bit more functionality, and it's designed to work with it perfectly. The price is about $20 to $30 per unit. You usually get classroom sets under $300. If you do adopt code.org curriculum and teach at least 5 students, 2 units, you can, and your school is a free reduced lunch school, you can actually get a subsidy to reduce the cost of the circuit playground. Some schools actually receive them for free, depending on where their free reduced percentages. So, like I said, lots of pieces to this, and they start using App Lab to control it. So again, we're going back to a tool that we learned using JavaScript, language that we've been learning, and now we're just learning how to control hardware with it. Yeah, buzzers, microphones, temperature sensors, all of those pieces are part of this little device. And believe me, I've thrown it around, I've dropped it on the floor. It's pretty sturdy. So, their goal, use the Maker Toolkit, which is App Lab with some special tools in it, to control that device. First thing that they do is they basically use it to create a controller. They're now creating a video game controller that they're doing this little emoji race game with. Then, their goal is to come up with that project of something that this could solve. Maybe it's turn signals for their bike. And making their first smart bike. So Unit 6 finishes things out with physical computing. So a taste of a lot of different things throughout the whole course of this course. From a resource perspective, all teachers have access to a curriculum guide. Each year they update the curriculum guide. So this year it's CSD 19. It's always whatever the year started with. So the 2021 school year, it'll be 20. Just because they make some edits, things like that to their curriculum. But it gives you access to all the units, lesson plans, teacher guides. Don't worry, I have a link at the end here to give to all of you to get the whole presentation. Teacher supports. You can become a verified teacher without going through code.org training. There's a link that you would fill out a form. Got to give them some information about your school, where you teach, things like that. They will send back to you to say you're a verified teacher. Once you're a verified teacher, you have access to answer guides, lesson plans, all the pieces you need as a teacher. Okay? Until you have that verified access, you don't get those pieces, because they don't want students to just have access to everything, right? Lesson plans themselves are well detailed. They give you all the pieces you need. Any resources are not only available in Word files, but Google document files that you can make copies of, you can edit, you can do whatever you need. From an assessment standpoint, they've updated their rubrics in the past year. They used to have 2-point rubrics, yes or no, and they got a lot of feedback from teachers saying, no, we want more point spread, like 4-point rubrics. They did it. They gave all of the qualifications for those rubrics, so you can certainly use all of those. They have some quizzes and other pieces throughout, but they remind teachers that the goal here is really use those projects as your assessment, because we want to make sure that the students are creating something and getting to that creation point. We talked about the tools that are available. They're all available free, the Web Lab, Game Lab, and App Lab. All the programming is scaffolded. Like I said, even when they move into that much more difficult JavaScript language, students can still use blocks with the language on top of it until they are ready to let go of the blocks. And like I said, from teachers that we've been working with, they say halfway through that Unit 3, kids don't want the blocks anymore. They want to type it out. They want to have more control over what they're doing. A lot of videos for instruction. From an implementation standpoint, like I said, we know that most middle schools aren't going to put this in a year-long course. Some split it up over 2 years, maybe 7th and 8th grade. Others I've heard say, what we do is in 6th grade we do units 1 and 2, and then in 7th grade we do units 3 and 4, and in 8th grade we do units 5 and 6. That all could work, absolutely. As long as you, of course, scale up. Everybody does units 1 and 2 year 1. A couple other options that they talk about are, you know what, maybe you don't have enough time. Maybe you only have options that you see your kids for about 5 weeks time frame. I hear from a lot of teachers that, you know, I'm part of a cycle, so I get 30 days with my kids. Well, over 5 weeks, maybe you just do an intro to web development. Start with some problem solving, jump into that intro to HTML, and that's what we get through, so we're at least exposing students to that. Or maybe we want to get to some interactive animations. so we could kind of manipulate that a little bit longer. So a couple of options there for implementation. There's nothing to say that you have to implement all 6 units for every student. You can certainly pick and choose those pieces, but the piece that you will always see stand out as a suggestion from code, and I certainly agree, always start with the problem solving. Even if you manipulate that chapter a little bit, change some of the activities, problem solving is the purpose of this course. How do we do all of this stuff through the lens of problem solving? So, code does give a number of options, but certainly I've heard teachers say, you know what, I started in Unit 1, but then I decided I wanted to jump right to Unit 4 because they kind of, I wanted to go from problem solving to going right into some empathy. And I said, well, did your kids struggle with the JavaScript because they didn't get Unit 3? Yeah, I had to go back and grab some of the videos from Unit 3, but we got there. Okay, as long as you felt comfortable to do that, that's great. So I've heard that sort of hopscotching method, and like I said, I had one teacher in Philly tell me, well, what I do is I just hopscotch. I love this part of this unit, so I did this. And then I hopscotch to this part of this unit. I was like, is it working for you? Are your kids getting results? Are they finishing projects? Yes. We're getting them a taste of computer science in the middle school. We're bridging from the block coding to our AP computer science courses in high school. We're getting that middle piece. What about, I still have to teach Word and Excel. Okay, let's talk about Excel. Is there a way that you can take some of that Excel out and include it in part of Unit 5? Oh yeah, we can do that. All right, so now we can get some of your Excel work in as well as something else. So we talk about ways that this might fit into another course as well. So believe me, I can tell you in the 5 cohorts of teachers I've worked with so far, I do not have 2 of the same implementations, even in the same school district. School district of Philadelphia, I can tell you, nobody in that district has the same implementation. But yet they're all making things work differently. So I certainly encourage you to think of it that way. So, now, the other option, join a professional learning cohort. This summer, we have 2 in Pennsylvania going on. On the eastern side of Pennsylvania, that happens to be happening at my IU. July 13th through the 17th is the start of it. Now, our cohorts begin in the summer. They're 5-day boot camps in the summer, and then they're followed up by 4 days of follow-up training throughout the school year. So that you're not left on your own throughout the school year as you're teaching this. In Western PA, Allegheny Intermediate Unit is hosting July 27th through the 31st. Again, as you go into code.org's website, there's a link to join us for professional learning over the summer. Put in your zip code, it'll direct you toward one of these 2 so that you can sign up for them. You'll see that there's a cost involved, but both sides of the state, based on our registration right now, we have a lot of scholarships available from code.org that we're going to be able to offer a lot of these positions for free. I know a lot of schools are looking at their PA Smart Money as a possibility for this as well. Remember, it's 9 full days of training when you're getting this professional learning. So, get a high level view of the curriculum, give you a better sense of what's part of it. I know it's a lot, and like I said, I usually do this in 9 days. For me to figure out how to put it into an hour was a little tough. Code.org doesn't give us the pieces for that. And you saw some of the curriculum in action. You saw how some of the pieces work. It's hard to give you guys a lot of hands-on work in this kind of setup with trying to show as much as I did, but hopefully you have a sense of what that would look like for your students. And then again, it's really about problem solving and how we use computer science to solve problems. So, did we learn something new about the curriculum today? Did I solve my problem for the day? Excellent. Is there something you want to know more about? This is your chance for questions. I tell you to work with elbow partners, but you're all pretty spread apart. Excellent. So hopefully you feel a little bit like this, and then you want to take this back and talk to your school about how you might implement computer science discoveries. I am ready to go do this. So, that link at the bottom is the link to this whole presentation. I'm sorry it is like 100 plus slides, but I tried to go through them in that amount of time. My email is up there, my Twitter handle. Please feel free to reach out. Any of us that are facilitators across the state work together. We are not in competition with each other. As much as we like to say east side and west side, we do work together. We're all trying to help teachers, especially at that middle level where I know it's really difficult to find the right fit for what you're going to do in the middle school for your students. Hopefully this might be the right fit for many of you. That's all I have. Please take that link.
Thank you.
You're welcome.